In this video, let us solve a couple of questions from kinetic theory of gases. The first question is from JEST 2021. We have to calculate the average value of Vx, modulus of Vx. Average value of any quantity in kinetic theory of gases, let's say A, average value of A, this is equal to integral A times f of V dV. Here f of V is the Maxwell velocity distribution function, or you can call Maxwell speed distribution function. There are different forms for Maxwell distribution function. The form that we choose depends on what quantities average we want to calculate. In this case, we have to calculate modulus of V of x average. Modulus of Vx average, this is equal to modulus Vx f Vx dVx. So we are choosing 1D Cartesian form of Maxwell distribution function in velocity space. This is equal to integral modulus of Vx minus infinity to plus infinity m by 2 pi kt the whole raised to 1 by 2 e raised to minus half mvx square upon kt dvx. This is the form of Maxwell distribution function in 1D Cartesian in velocity space. Therefore, we have modulus of V of x. Modulus of Vx average is equal to m by 2 pi kt the whole raised to 1 by 2 integral minus infinity to plus infinity modulus of Vx e raised to minus mvx square upon 2 kt dvx. Now this is even function, therefore we can write m by 2 pi kt the whole raised to 1 by 2 times 2 integral 0 to infinity Vx e raised to minus mvx square upon 2 kt dvx. Now there is standard formula to solve this integral, but sometimes you have to do integration yourself. Sometimes you forget these formulas. Let's do one thing. You substitute mvx square upon 2 kt is equal to u, then du is equal to mvx upon kt dvx. This implies dvx is equal to kt upon mvx into du. When vx equal to 0, u is equal to 0. When vx equal to infinity, u is equal to infinity. So limits are same. Let us do it. Average value of modulus of Vx, this is equal to, constants are m by 2 pi kt the whole raised to 1 by 2, then there is a 2 as well, times 2 integral 0 to infinity Vx is equal to, let's write Vx as it is, Vx and e raised to minus u dvx is equal to kt upon mvx du, kt upon mvx du. Vx gets cancelled, e raised to minus u du from 0 to infinity integral. This integral is equal to 1. kt upon m can be taken outside, and integral 0 to infinity e raised to minus u du is equal to 1, because you will get e raised to minus u with a minus 1 from 0 to infinity. This is equal to e raised to minus infinity minus e raised to minus 0 with the negative outside. This is equal to minus of 0 minus 1, this is equal to plus 1. Therefore we have average value of modulus Vx is equal to m by 2 pi kt the whole raised to 1 by 2 times 2 times kt upon m. This is equal to root of 2 kt upon pi m. Now when you calculate the average value of Vy modulus, then that will also be equal to root of 2 kt upon pi m. This will also be equal to average value of modulus of Vz, because there is nothing special about x direction. All of the directions are equivalent. In all the directions the motion of the particle is random. Therefore there is nothing sacred about any particular direction. All of them are same, all of them are equivalent. If you calculate something for x direction, it will be true for y direction and z direction as well. The correct answer in this question is option D, root of 2 kt upon pi m. Now let us move on to a question from JEST 2023, which is also from kinetic theory of gases. We have to compute the value of this quantity. Here average of modulus of V of x is root of 2 kt upon pi m. When we square it, we will get 2 kt upon pi m. It is also equal to average of modulus of Vy square, which is also equal to average of modulus Vz square. Therefore in the denominator we have this quantity, which is equal to 6 kt upon pi m. So this is in the denominator. In the numerator we have average of modulus of V vector squared. Let us find average of modulus of V. This is simply equal to average of V. This is equal to integral V f of V dV. Here let us put the Maxwell's velocity distribution formula for 3D in spherical polar. F of V is equal to m by 2 pi kt the whole raised to 3 by 2 V square e raised to minus half m V square upon kt d omega integral over d omega. Here d omega is equal to sin theta d theta d phi. If there is no angular dependence, if there is no theta dependence or phi dependence in the quantity that we want to calculate the average, then integral d omega this will be equal to 4 pi, because we know integral sin theta d theta integral d phi from 0 to 2 pi, theta ranging from 0 to pi, this is equal to 4 pi. You can see that there is no dependence of theta or phi in V. Therefore we can write average value of modulus of V, which is equal to average value of V. This is equal to 4 pi times m by 2 pi kt whole raised to 3 by 2 integral, there is a V here and there is a V square in Maxwell distribution function. Therefore we have integral V cube. Integral runs from 0 to infinity. Here raised to minus half mv square upon kt dV. This is in the format integral 0 to infinity x raised to 2n plus 1 e raised to x raised to 2n plus 1 e raised to minus ax square dx, and it is equal to n factorial divided by 2 into a raised to 2n plus 2 divided by 2. Here n is equal to 1, a is equal to m by 2 kt. Therefore average of v is equal to 4 pi times m by 2 pi kt, the whole raised to 3 by 2 times n factorial is 1 factorial divided by 2 times a is m by 2 kt, the whole raised to 2 into 1 plus 2 divided by 2, that is square. Therefore we have this is equal to 2 into 1 by root pi times root of 2 kt upon m, which is equal to root of 8 kt upon pi m. Let's substitute it here. Then we will get, when we square it, we will get 8 kt upon pi m, and in the denominator we have 6 kt upon pi m. Therefore this quantity it will be equal to 4 by 3. Now it is not practical to derive all the results during exam, so you can remember some of the results. The average value of Vx, average value of Vy, or average value of Vz, all of them are equal to 0. But when you take modulus of Vx and then take average, this will be equal to root of 2 kt upon pi m. The average value of Vx Vy is also equal to 0. Average value of modulus of V vector, which is simply average of V, is equal to root of 8 kt upon pi m. So these kinds of results you can remember. Let's wind it up here. Thank you.